Next, we're going to look at actually finding limits. And so we'll look at 4 examples, and these are, again, just general ideas of what a limit is, and hopefully it helps you understand what that notation above meant. So we have the limit of the function x squared minus 9 over x minus 3 as x gets closer to 3. Let's actually look at this graphically first. So let's put in our calculators. Let's see where it is. Here we go. The function x squared minus 9 over x minus 3. And then let's see what's happening in our calculators. So menu graph. And I encourage you to do this with me. I might show you something you don't know. We'll see. Over x minus 3. Okay, well, at first this looks like, I'm going to move around a little bit. This just looks like a line. And it is almost a line, but not quite. And we can see this is not the equation of a line, x squared minus 9 over x minus 3. It's not in the form mx plus b. So why does it look like a line? We'll see that algebraically in just a moment. But we can press Control T and look at the table. And we can actually see that at the value 3, our function is undefined, which should make sense because we can think, well, if x were 3, we would divide by 0 and the function is undefined. But what we are interested in is what's happening as the x value is getting closer and closer to 3. What is the y value approaching? And we can press Menu, Table, and Table Settings. And let's just change our table settings. Let's start it at 3, and let's change the table step to 0.1 or even 0.01. Let's just start with 0.1. So what that's saying is I want to look at x equals 3, and I want the x values to change by 0.1. And what I can see is that as x is getting closer to 3, look, I can see 2.6, 2.7, 2.8, 2.9. What is the output getting closer and closer to? Well, it looks like the output's getting closer to 6. And same with from the other end. As x is getting closer to 3, 3.5, 3.4, 3.3, 3.2, 3.1, the y is getting closer to also 6. And that means that the limit as x is getting closer to 3, so from both sides, as x is getting closer to 3, y is getting closer to 6. Now, it can't ever be 6. We actually know that it's impossible for it to ever reach 6 because when x was 3, the function is undefined. But that's not what a limit is saying. The limit is saying as x is getting closer to 3, what are the, from both ends, what is y getting closer to? And so we can see that the limit of this function as x approaches 3 is equal to 6. And we could see that graphically. Now, why does that work algebraically? Well, if I take that function, x squared minus 9 over x minus 3, I can factor the numerator into x plus 3 times x minus 3 over x minus 3, and cancel out the x minus 3's, and I end up with simply the function x plus 3 with the restriction. So it is the function f of x is just x plus 3, the line x plus 3, but with the restriction that, remember, x is not allowed to actually equal 3, because if x were 3, the function is undefined. And so x cannot equal 3. And this is simply a line with a hole in it is what it looks like. So if I were to graph f of x, it is a line with a y-intercept of 3 and a slope of 1. 1, 2, 3, and it has a hole at the point 3, 6. And the way we actually graph that, this isn't that important for this class, but it's a line like this, and then we put a little hole here. The graphing calculator doesn't show you the hole, but there is a hole there, and we could see that from the table in the calculator. Okay, the next problem is x squared plus 9 over x minus 3. Well, let's also look at this one graphically. Oh, wait, there's something kind of weird here. This says x approaches 3 with a positive there. What that means is as x approaches 3 from the right, as x approaches 3 from the right. Well, let's look at the graphing calculator and graph this x squared plus 9 over x minus 3. I'm going to press Control T to get rid of the table again. I'm just going to press Tab and up and change this to x squared plus 9. Okay, I can't see much yet. Maybe if I zoom out a little bit, menu, zoom, I'm just going to zoom out once with the center here. I can't really see actually at this point what's happening as x is approaching 3 from the right. Oh, look, if I move this way, I can. And this is pretty strange here. I can see that it looks like, again, x can't be equal to 3 in this equation because it would be undefined function. But it looks like as x is getting closer to 3 from the right, the outputs are getting really, really large. We can also see that from the table, Control T. And I can see now as x approaches 3 from the right means as x approaches 3 from a number that's higher than 3. What I'm going to do is I'm going to, again, menu, table, and edit the tables. Oh, no. Edit table settings, menu, table, edit table settings. And I'm going to start it at 3, but I'm going to change to 0.01, a really small step. And as x approaches 3 from the right side, from the higher values, the values above 3, well, what are happening to the outputs? They're getting infinitely large. At 3, the function's undefined. But as x is getting closer to 3, from the right or from the higher values, x is getting infinitely large. As x is approaching 3 from the smaller values, from the left side, I can see that x is getting really small, and I can see that on the graph. There's actually a vertical asymptote here at x equals 3. So as x is approaching 3 from the left side, if you can look at my cursor, the outputs are getting infinitely smaller. As x is approaching 3 from the right side, the outputs are getting infinitely larger. So let's go ahead and fill that in on our sheet. As x approaches 3 from the right, the limit is positive infinity. Some textbooks don't like writing infinity as a limit. IB is okay with that, and I think AP is too. But just be warned, in college, some people say you can't say that the limit is infinity because infinity isn't an actual number. But we are okay with that in our course. The limit as x approaches 3 from the left side we saw was negative infinity. Now, if I asked you what the limit as x approaches 3 is in general of that function, as x approaches 3 in general, well, this limit does not exist because it approaches something different from both sides. From the right side, it's going up. From the left side, it's going down. So if I say, what's the overall limit as x just approaches 3 in general, it does not exist. There is no limit. Does not exist. Okay, let's look at one more. The limit as x approaches infinity, as x gets infinitely large of this function. So I'm going to open up a new graph and graph that function. That's 1 plus 1 over x raised to the x power. This may look familiar to some of you. Maybe you've seen this function before, sometimes with an n in it. And we're not concerned about all this inner part here. What we want to know is as x gets infinitely large, as x gets really, really large, what are the outputs getting closer to? And it does look like they're reaching a stable position. It looks like they're reaching a stability here. There is actually a horizontal asymptote that this function, if I keep going and keep going, I'll see, look, it's just reaching like, almost looks like a horizontal line eventually. Well, if we look at the table, Control T, we can see as x gets really, really large, I'm just going to go up, 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 2.709, 2.10, 2.713, 2.714. And what x is getting closer and closer to is the number, our favorite mathematical constant, maybe in this class, is E. It's getting closer and closer to E. And this is actually the definition of E. E is defined as the limit as x approaches infinity of 1 plus 1 over x to the x power. And we can even check and see. We can even just really see e to the first power is, oh, let me say Control Enter to get the approximate. There we go, 2.71828.